This is Jackson Wright with Project 3. Here's my demo on my Unity Pathfinding algorithm comparison project. So first thing, once you load the project into Unity through all the necessary file loading, scene loading, etc. stuff, you just hit the play button and you'll be given this UI, and it will ask you, do you want to make a pre-made grid or a rectangular grid of your custom size? And it will help, and it will compare those algorithms. So let's click Basic Grid. So here we are. There's 3 grids. The one on the left, the leftmost grid, will be the best first search. The one in the middle will be the Dijkstra's algorithm, and the one on the right will be A star. So you can click Start Animation down at the bottom, and they'll slowly play through their animations. As you can see, the others finished really quickly. And that's done. You can also restart it, start it again, pause it at any time, step forward frame by frame. Here's the frame by frame step forward, just to watch it. I'm clicking it manually. So again, one at a time, pretty cool. You can also speed up and slow down the animation. Now it's playing automatically. I'm not stepping forward, but it's doing that itself. So let's do a different grid this time. Let's do a little snake-like path. So yeah, if the grids are too big, you can scroll through them with the right mouse button. So let's start the animation. As you can see, best first search finished really quickly. I'll restart and show Dijkstra. We should go real slow. Here, I'll actually do these both at the same time. Remember, this is Dijkstra and this is A star. Dijkstra is on the left. So A star traces out the same path essentially as Dijkstra. In length they'll be the same, but it's faster. As you can see, it didn't finish as many nodes as Dijkstra did. A finished node is the stone pattern, a frontier node is the dirt pattern, and a non-visited node is the grass pattern. Whereas the little boy with the hat on and the gold star are the start and destination. So here's the custom grid maker. Let's make a pretty big grid. Let's not do 300, let's do 30. As you can see, it's too big to fit them all at once, but you can scroll through them. Let's just watch A star, because that's the one we're interested in. And it's gonna finish really quickly, because A star's smart. As you can see, best first search also finished just as quickly, because it was a empty path. Dijkstra takes a while, so we're gonna reset. Now we're going to draw some walls just by clicking here. We can even drag the start here and drag the end here, like so. So A star will try and go for the most optimal path, find it's not possible, and will slowly try and spill over one of these edges, and the second it does, it's going to rush right towards the end, like that. Boom, and it finds the most optimal path. And yeah, and you can draw on all of these. Do as you will. Let's start one really fast. So watch Dijkstra finish as the wavefront approaches the end. And as you can see in the top right, let's reset. You can watch the heuristic step through. So the heuristic will say the most recent stone tile is the one it will give you the information for. So as you can see, the total priority is the sum of just the Dijkstra distance from the start and the heuristic from best first search. And if you get to the end, it will say path found, and it will give you the distance in Dijkstra that it would take to get to the end here. Each of these bricks is about, I believe it's slightly less than half a meter. So if this is around 20-ish cells, a little less, then this distance is around 11. And it took 162 steps for A star to finish this. And that's about it. Really